All right, so this is the problem here. Find maximum number of string pairs. You are given a 0 indexed array words consisting of distinct strings. So they're all different. There are no repeats. The string words I, so the individual strings, can be paired with the string words J. So this one with this one, or this one with this one. The string words I is equal to the reverse string words J. And I is less than J. I is greater than 0 but less than words length. J is greater than 0 but less than words length. And J is always greater than I. So you're never going to be comparing a string against itself, essentially. So that's just a little bit of information for how we iterate over this, depending on the strategy that you use. So return the maximum number of pairs that could be formed from the array words. Note that each string can belong in at most one pair. So if I start with CD and I'm looking through here and I see, okay, there's DC. So this is the reversed version of CD. So boom, we have one. And then since it says that each string can belong to at most one pair, that means that when we reach here, even if we find this one here, we don't increment count by one again. So if we encounter a string and we find its reverse, we increment it by one, and then we forget about both of those. Neither of those matter anymore. The reason this one is 2 is because we also encounter AC and CA. And so that will increment our count to 2. And then ZZ, that was actually an edge case I had for one of my solutions, and I had to work around it, but yeah. So in this example, we could form 2 pairs of strings in the following way. We pair the 0th string with the second string as the reverse string of word 0 is DC and is equal to words 2. And then we pair the first string with the third string as the reverse string AC equals CA, and that equals this one here. It could be proven that 2 is the maximum number of pairs that could be formed. With the second example, we only have 1 because AB and BA, so that's going to be 1 pair. CC, there's no pair. And you know that there's going to be no pair because with palindromes, where there's just 2 of the same character, because distinct. They're distinct. So if we have CC, there's not going to be another one CC. So we could just ignore palindromes. And then for the third one, 0, because AA, it's a palindrome, so it doesn't matter. And then there's nothing to match AB. If we had a BA, then that would be 1. But so the length of the array we're given is going to be anywhere from 1 to 50, tiny, tiny. And the length of each word is going to be 2 characters. So they're all going to be only 2 characters. Words consist of distinct strings, so they're all different, and words I contains only lowercase English letters. So I'll go ahead and share the live share link.
I have some questions.
Cool.
Could you please go back to the problem?
Yes, sir.
So I'm not sure if I understand. Like you have to find the reverse of a string and
Yes.
count it.
Yes.
But it like if you have ZZ and or ZZ and ZZ, like if you have 2 of those, they're the reverse of each other.
But they're
Palindromes.
yeah, but they're distinct strings. So if you see ZZ, there's never going to be ZZ anywhere else because there's no repeats. And also, you have to match
There's no repeats. Well, is
because
that a rule?
yeah, so you're given a 0 indexed array words consisting of distinct strings. Distincts mean that there's not going to be any repeats. So if we have CD here, CD is not going to be anywhere else. If we have CA here, CA is not going to be anywhere else. So,
Okay.
so they're distinct. Since you have ZZ, ZZ is not going to be anywhere else.
So there's no risk of there being like CD or ACAC or
Mm,
DCDC or
Exactly.
okay.
Yep.
Okay.
And then you're just looking for a reverse that matches. So if we find CD, that means we're looking for a string somewhere in the rest of the array that is the reverse of this. So we're looking for DC. If we see AC, we're looking for CA. If we find DC, we're looking for CD. If we find CA, we're looking for AC. If we find ZZ, we're not looking for anything because it's a palindrome. You know that reverse is not going to be in the, because they're distinct.
Okay. Okay, let me try.
Does that make sense?
Yeah, it does.
Um, does that make sense to you, Liz, as well?
I'm not sure if it does. We'll find out.
Cool. You gonna give it a shot?
Yeah.
All right. Cool.
I opened this.
Are you in the code editor? I'll create a couple files for you too if you would like. Liz. Call it liz.js. And Daniel, if you come in.
Yeah, I'm coming soon. I'm just trying something.
Cool, cool. Cool, cool. And then if either of you are just like, I just don't know how to think through this, just let me know and I'll walk you through it. But
Okay.
What are you thinking, Daniel? What strategy are you going with?
I'm trying something with set, but first I need to uh, eliminate any string that's like what is it called again? Uh, when they're all the same character.
Palindrome. Yeah.
Yeah, I need to eliminate those somehow.
Okay. Cool, cool. That's a valid method with a set. What are you thinking, Liz?
I'm researching. You would split somewhere, right? To kind of.
Um, are you saying to get the reverse string?
Yeah, which is
Yes. Yes.
like getting the pairs. I might be lost in
Yeah, so with the to get the reversed string, you'll have to split the word to create an array of characters. You'll reverse that and then you'll join them back together. So that's just method chaining right there. I'll go ahead and so you would do something like this. Like if you had AB, you would want to split, reverse, and then join. So what that's going to do is the split is going to execute first. So it's going to turn that string into this. Then reverse will run on this array. So it'll return that. And then you'll run join on this. Here, let me make it more clear. Join on this, and then that'll just recombine them. But eventually you would, essentially you would just chain them all together. But that's two solutions I was looking at. One of them was a brute force solution, and the other one is similar to Daniel's, a set. So
Yeah, I'm having an issue where I can't sort the elements inside of the array. I don't know what I'm doing
sort,
wrong.
sort.
Yeah, okay. I'm gonna show you the code. What I'm trying to do, but it's just something probably silly because for the life of me, I can't debug anything. As you, okay, so let me do this. Yeah. So if you take a look at my file, are you taking a look at my file?
Mm-hmm.
I decided to think, okay, let's first of all get rid of every single palindrome inside word. So I'm looking at the thing, and if the word is equal to, oh, it's not sort, it's reverse. I don't know if it's gonna work anyway, but like if it's equal to itself in reverse, is it reverse or is it sort? I don't know. Yeah, it's something like that. Then we remove uh, the the thing from the array, and then we'll have a clean array, right? Like clean the array by removing palindrome. Uh, Create a set. Uh, Wait, let me create a set. Uh, so so we mm, That doesn't make any sense because they're all distinct, right?
Yes.
I don't even know
Yeah.
where.
Yeah, they are. They all are distinct. I was gonna use a hash map, but I realized that it didn't make sense to have a hash map because they were distinct and there was only one instance of each one, and so I did decide to go with a set.
Yeah, but
A set as well.
is this set really doing anything?
Yes. Well, I'm using the set to. All right, so I'll just break down
Yeah,
what I'm doing.
it's just frustrating.
Yeah, so basically, I do the same thing you're doing here, where I'm checking for the palindrome, but instead of iterating over the array to check for palindromes first, I just write a case to handle that. And so we start with this array, right? And we're like, okay, we want to create a set. Why do we want to create a set? Because deleting from an array is going to end up being in O of n solution. So if if we're like iterating through this array and we're like, all right, starting at 0, moving to 2, oops, moving to 3, moving to 4, and for each one we're like trying to find one that matches, that's already O of n. That's as brute force as it gets. And then if when we encounter the matching one, we remove this one and we remove this one, that's another O of n inside of already an O of n squared. So it starts getting really complicated really fast. And so the reason for the set is because if I want to delete something from a set, it's an O of 1 operation. I actually thought for a while that it was O of n because I was like, all right, if I'm deleting something from a set, it's like similar to splicing from an array, but it's actually not. Under the surface, a set is basically built with similar implementation to a map, but it kind of like looks like an array. So what we do is we create that set, like you said. So you're right about that. We have our set. And we initialize our count to 0, right? So now we have our original array, we have our set, and we have our count. At that point, we have everything we need. So at this point, now we want to iterate over this nums array, just starting from 0. So when we get to 0, we check. Let's just say, all right, so I equals 0. So word I equals CD, right?
Yeah, I guess.
So currently we're on this element here.
Yeah, I was trying to think something like there.
Yeah, so we're targeting this one here, and so what we want to do is we just want to get the reversed of that. And so to get the reversed, we just do word I dot split.
Why split?
Because you can't reverse a string. You have to convert it into an array.
Sorry, what?
You can't. You're not going to be able to run reverse on a string. Reverse is not a.
But word I is a string.
Yes.
You can't reverse a string.
No, reverse is not a method that exists on strings.
What the hell?
Yeah. So.
That's so weird. You have to create an array for no reason.
Yeah. Well, it's O of. Yeah. Yeah. Well, it's not for no reason, but yeah. You do have to create one. So yeah, you have your.
Is it kind of because like the string is being looked at as like a whole versus individual letters? Is that like how we can make sense of it? Why we have to split it up?
Why is there no reverse method within a string? Is that what you're asking?
To try and kind of like make sense of it, or the way I'm trying to make sense of it is like if I'm just using like layman's terms, like the computer's not looking at it as like C and D, it's looking at it as a whole thing of CD, where like we've got to separate it into C and D for our purposes.
Yeah, I don't know. I don't know exactly why reverse isn't built into the string. It might be in like a newer version of JavaScript, but I'm using ES6 like most people. Though some people do choose to use the experimental versions of JavaScript, and there might be something for reversing strings in experimental versions of JavaScript. But yeah, as far as like ES6 goes, the industry standard for JavaScript, there's no reverse built into the string. And I believe that it has to do with the fact that strings are immutable and arrays are mutable, but I'm not exactly positive. Yeah, just if I want to reverse a string, I split it into an array, I reverse the array, and then I join it back together into a string.
Okay, yeah, just show me the solution, man. I can't think of anything really.
Yeah, it's
It's
all
so
good.
long.
It's all good. So yeah, so we all right, I don't want to like start halfway through the explanation, so let me just all right. So we started with our array. We converted our array into a set so that we could just keep track of what we've encountered so far. So basically, if we encounter CD and the reverse exists in our set, we could delete both of these from our set with an O of 1 operation. Whereas with an array, it's going to be an O of n operation for each delete. So if you delete this, O of n. If you delete this, it's O of n. So it's just way more efficient to just do this set here in the beginning. But once we have the set and the count, we have everything we need to start iterating over the array that was passed into the function. So we start at CD, I equals 0, word I is CD, so that's our current string. We reverse our current string with word I, split, reverse, join. So we end up with our reverse actually equals DC at this point. And then what we do is the first thing I did was I checked to see if it was a palindrome. So I did if word I 0 equals word I 1. I knew that the characters were the same, and I just continued. But I'll comment that out for now. What we want to do is we want to check if our set has the reverse of our word. So we basically just do set has reverse. If this is true, then we increment count. So let's just say our current word is CD. Our reversed version of CD is DC. We check our set to see if DC exists. Set has reverse. It does. There's a DC in here. And since there's a DC in here, we do set delete word and set.
Why delete the word instead of just adding to the counter?
Because if you don't delete CD and reverse DC, then I guess you don't have to delete word I. You don't have to delete word I, because if you delete reverse, you're gonna delete reverse, and you're never gonna encounter one where like the opposite is this. So like if our word is CD and we check to see if the reverse exists, so DC, and it does exist, I guess we could technically just delete DC, because then we don't have to worry about this one. But I just cleaned it up anyways. I personally cleaned up both of them, but it's preference at the end of the day.
Yeah,
They're both.
what I thought is like you just find if there's a word with a reverse, and then you add up to the count, and then at the end you just divide it by 2 or
The,
something like that.
Divide by 2?
Yeah, because like CD and is gonna be we start with CD, right?
Yes.
Then you find DC,
Yes.
and then when you go and you start at AC, you find CA. So far you have 2, right?
Yep.
You count 2. So when you start DC, you find CD. That's 3. And when you start at CA, you find AC. That's 4. If you divide by 2, that's 2. This is the result.
So instead of deleting, just divide by 2.
Yeah, just count the occurrences and divide by 2.
Yeah,
That's how it works.
that works. That would totally
That's how
work
you
too.
word palindromes.
Yeah. Um, yeah, that would totally work.
Okay.
It's just implementation. So you could delete just the word. You could delete the word and reverse. You don't have to delete anything. Like you said, you encounter CD, you check for the reverse, it does exist. You encounter AC, check for the reverse, it does exist. Encounter DC, you know if you encountered CD and the reverse exists, that when you encounter DC, the reverse also exists, so you'd have 3 at that point. Same thing with CA, the reverse exists, so you'd have 4. And then you know that you could just divide by 2. So that works. That works. It comes down to implementation. Let me think, because if I have a set of like 100, right, and 50 of them are matches, and they all have a pair, then with this method where you delete them, you're going to do 50, you're going to increment count 50 times. But if you keep them all in and you double up, so you encounter CD, then you encounter DC, and you also increment count, you're doing 100. So it's double the number of calculations. At the end of the day, though, like someone who's savvy with O1 notation, they know that it's still O of n. Because it's either with the solution you're saying, it's O of n. With the solution I'm saying, it's O of n divided by 2. But it's still O of n at the end of the day. And same with if you do count divided by 2, that's an O of 1 calculation. And also set dot delete is also an O of 1 calculation. So at the end of the day, it's just like semantics. It's just implementation details at the end of the day. As far as efficiency goes, they're both the same. So either or works. Yeah. Yeah, and then you just iterate through like that. Do you want to try to give it a shot to solve this one now that I broke it down a little bit and you could just code it up in the method you were using?
I think I'm gonna skip today. If you want to do it.
Yeah, no worries. I'll go over to file 2, and I'll just.
Tired, sorry.
Yeah, me too, man. I've been tired all day. Honestly, I got bad sleep last night.
Yeah.
I have a question.
Yes.
Can you search these individual problems that you're giving? Like in LeetCode?
Search?
Yeah, so you know this is problem number 22 something or other.
Yeah. 2744.
Potentially search for that, like on
Yes.
my own in LeetCode?
Yes. In LeetCode, if you go to problems and then there's a search questions bar, and you just type in 2744.
Alright, let me scroll down far.
Yeah. Yeah, you could search for these directly.
I just use the number in Google. LeetCode number. And then
Oh, okay.
Yeah, that works too.
Also works, yeah.
So first thing we do is we just create our set. We need a set to kind of like delete or go through, a way to store our values. Yeah, you could do it with an array, but it's going to end up being less efficient. Then we initialize our count variable so we could keep track. And then we just iterate over words. So we iterate over the array that we were given. I'll go ahead and do it with just let word of words. And then the first thing I want to do is I want to create the reversed version of the current word. I want to check if it's a palindrome. Just skip it. If the reverse of our current word exists in our set, increment count, delete the current word. I don't know why I want to delete the current words. You pointed it out to me. I'm like, why do I want it? Like, it just feels natural for me to reverse it. It's probably because I've done so many problems and like, it's probably like biased from doing other problems where like I probably had to delete it from other, but it just feels right to me. I don't know. Like you technically don't have to, but I don't know. It just feels good. It feels nice to like clean it up as I'm going along. I don't know what it is exactly though. Okay, and then return count. All right, so we will create our word set, and we could just pass in words like that, just like you did, Daniel. Let count equals 0. And then we'll create the reversed version. That'll give us our reversed word. I want to check even before I do any checks if it is a palindrome. And I could probably check this before reversed. I don't want to create this if I don't have to. I don't want to have to create the reversed word if I don't have to. So if word 0 equals word 1, so I'm just checking if the first character is the same as the second character. Just continue. Just skip.
Continue is something I never really use, but it basically just skips the iteration.
Skips everything underneath it and just starts the for loop with the next word.
What about break?
That would break out of the loop entirely, and it wouldn't do the next iteration.
Okay.
Yep. And then if our word set has reversed, then we just increment our count. We do word set delete word, and we do word set delete reversed. But like Daniel said, we could cut this out entirely. We could just increment it every time it has the reversed.
And return count divided by 2.
And then return count divided by 2. That would also work.
Yeah, try both. Maybe there's an edge case we are not aware.
Let me see. Reversed. Yeah, let's try this out. Yeah, 210. Looks like it's working. Let's put it in LeetCode and see how it performs. Word set has reverse count plus plus. Nice.
That's pretty good.
Yeah, that's really good. I like that. That's cool.
Yeah.
We have a couple more minutes though, so I'm going to go ahead and show you just the brute force solution. This one is, there was no other solution that really made sense besides these two for a small problem like this. I did try a bit manipulation solution just to wing it and kind of like push myself, but it's just such a specialized skill. It's tough for me, but brute force is not using a set. So with this set solution here, this set is making our memory. So if we do, what's our space complexity? Space complexity is O of n. And our time complexity should be O of n. With the brute force solution, though, we're looking at space complexity. Yeah, space complexity is O of 1. Com complexity, like Daniel said, is O of n squared.
Because you're going to do a for loop inside a for loop.
Exactly, exactly. So with this one, we'd basically have I and j. So we have our outside for loop, and we'd have our inside for loop, and we'd start I is 0. We'd start j as I plus 1. So it'd start as 1. And we'd compare this to this. And if the reverse of this equals this, or the other way around, you just reverse one of them and see if they're equal. If they're not, then you move j to the next one, reverse this one, and see if they're equal. They are, so we'd increment count. Go here, reverse this, see if they're equal. Same here, go to the end, see if they're equal. If they're not, you would just increment I to the next one and reinitialize j as I plus 1. So start right here. And then same thing. Check these two against each other, reverse one of them, see if they're equal. Move j, reverse one of them, see if they're equal. If they're equal, increment count. Same thing. Reverse one of them, see if they're equal. And then since j is at the end, the loop starts over. J equals I plus 1. So you're slowly just moving down. You're literally, for every element in the array, you're checking every other element in the array. So it ends up being O of n squared. And I think it's simpler and more straightforward than the set solution. It's definitely an easier solution. It's just much less efficient, and you don't want to use it for like bigger arrays. So
yeah, also for job interviews.
I would use it for a job interview, but if I was gonna, I would start with this one, and then I'd say, this is a good one, but this is O of n squared, and I want to come up with something a little bit better. Do you mind if I improve on it? And if they said no, and they were like, we just don't have the time for that, then I would be like, all right, well, at least I could let you just know about it really quick if I was able to optimize on it, and I would just let them know about the other solution that's in my mind. Like, I would use a set. I'd kind of like explain it to them. But hopefully they just gave me enough time where they're like, yeah, go ahead, feel free, you know? So initialize count to 0. We're only using a count variable. Iterate over words. Iterate over words. Check if current string equals reverse of second string. Increment count, and then just return count. I don't know why it keeps doing that. Do one of you guys want to give this a shot? Feel free.
Go ahead, Liz.
No, I'm good.
Your time to shine.
Come on, Liz, you got this.
Well, I mean, setting count to 0 and let count equal 0, right?
Yeah. Nice.
So is this still a for loop? Like, you kind of lost me in the
Yes.
example of going over and over.
Yes.
Like
So,
pairs.
yeah, so this is just going to be a for loop. Yeah.
That's my brains.
You're good.
No. So no loss in what site make I here.
Mm-hmm.
I equals what? Words.
So the first one is just where you want to start I as. The middle one is the condition you're checking after each iteration to see if you want to continue running the loop. So you want to run this loop while I is less than the length of words. There you go. Because once if we have like 8 words, once I gets to 8, we want to break out of that loop. Because we don't want to go outside the bounds of the array.
Are we doing I plus plus?
Yes. Yes. Because you only want to move one word at a time. Perfect.
So then when we iterate over words again.
Yes.
What is that?
But this time, so the first loop is I. So you start at 0, you go to 1, you go to 2, you go to 3, you go to 4. The internal loop is not going to start at 0. The internal,
That is J.
yeah, you want that to always start one spot ahead of I. So if I is 0, you want J to start at 1. If I is 3, you want J to start at 4. If I is 100, you want J to be 101. So you could basically start it as like J equals I plus 1. You just want to start J at the next position. Make sure you do the curly. There we go. There you go. Cool. That's that.
Be I plus 1?
Yes.
Or am I not doing that right?
No, that's right.
Or would just be I plus plus, right?
I plus 1. I plus plus would actually change I.
That would just be incrementing out.
Yeah. And it would also give that incremented value. I think it would give J the correct value, but it would also increment I, which you don't want to do.
It's still the same here when we're doing words.
Exactly. You want J to move from the left to the right until it reaches the end of the array. Yep. Perfect.
And then I'm still doing another curly bracket or no?
Yep. Right there. And then we'll put the rest of the pseudocode in there. So current string is going to be the I, and then the second string is going to be targeted with the J.
Okay, how would I depict that?
So let me try to explain it in a way that doesn't give you the answer. All right, so if I wanted to target this string right here, I would use word 0, 1, 2, 3, 4. So words 4 would target this string. What would I use to target this string? Words 2, exactly. What about this one?
So that one's 0. So is it the index?
Exactly. I don't want to use like literals. I don't want to use numeric literals like 4 and 0 and 2 because then it'll process the same string every time. I want the words that I process to be determined by I and J. So instead of putting a 4 in here, or instead of putting a numeric literal in there.
Oh, okay. Am I doing like I?
Yeah, well,
my eyes don't want to do
we're
that.
so we're using words 4 to target this. But if I want the word that I'm targeting to change every time, I can't put a literal in here. A literal is just like a 4 or a 7 or a 10, because if I put a literal in here, it's going to be the same one every time. Like if I did if word 4 equals word 2, then I'm always going to be comparing this against this. But I want the words that I'm comparing to change. And the only thing that's going to change the words that I'm comparing is this right here. So instead of using a numeric literal, because a numeric literal will give me the same string every single time, I need to use variables. Variables that are changing every time. And in these two for loops, the only things that are changing every time is I and J.
I'm saying, is that what we would do?
Yep.
Equals words J.
Yep.
How is that like? I'm way overthinking it.
Perfect. Yes, because now on the first iteration, I is going to be 0, J is going to be 1, so you're going to compare this word with this word. And then J is going to move to 2, so you're going to compare this word with this word. Then J is going to move to 3, so it'll be this word with this word. J will be 4, this word with this word. And then J will be at the end, so I will increment from 0 to 1. So I will be 1, J will be 2, and same thing. J will move all the way down, then I will increment, and so. Cool, so if words I equals words J, so words I is never going to equal words J because every element is distinct, so you're going to have to reverse one of them. I went with reversing the second one. So that same thing that I showed you in the other example where you have to convert it to an array, reverse the array, then join it back together. Yeah. Cool. So if words I equals the reverse of words J, then just increment count.
What do I do? Count plus equals 1. The same thing, right?
Count plus equals 1 also works. They both work.
Okay.
Yeah. I usually go with count plus plus. It's just, I don't know. All right, let's test this out, see if it works. There might be a problem with it, but let's see. Yes. So I believe the only thing is reverse is just going to reverse, but I believe in split and join.
Yeah.
You just have to put those strings and you should be.
Oh,
Yeah, there you go. 210.
Nice.
That's it right there. Let's post it in LeetCode. Make sure it passes all the test cases. Damn, Daniel, 99 and 96. So rare do I see that.
Yeah. That was a good solution, right?
Yeah, that's interesting how a small modification like that can make such a big difference, though, because I did test the set earlier. Yeah, the one that I had, and it was 27 and 5.
Yeah, but that's a good solution. It should be higher.
Uh, Actually, no, it wasn't 27 and 5. It was 74 and 55.
If you post the same one again, it's probably not gonna be that efficient. Like the one divided by two.
Divided by 2.
Yeah, the one where we divide by two, that was super efficient. That was probably just
I don't know. You are cutting a lot of code out of it. But you also are doing split reverse and join more times. So yeah, it's huh. That's yeah, it's pretty solid. It's good.
yeah. It's not. I'm sure it's not 99%, but
Nah, I wish I had a way to test them like
yeah,
evenly. I guess that's why we use big O notation though, right?
exactly. Yeah.
Yeah.
You know, there's so much difference between servers,
I
cost
know.
of power, and all that.
I know, especially in like certain parts of the world, you're never gonna get close to the same computing power we have here.
Yeah.
All right, so that's that. It's nice to see Liz type a solution out too. How did it feel?
Feels all right. Yeah, definitely helps to talk stuff out.
For sure, for sure. Cool, cool. All right. If do you guys have any questions before we hop off?
No, I think I had a hard time with this problem, but I think I'm tired. But yeah, uh, the thing that I missed was the continue keyword. I thought I had somehow get rid of the palindromes with like filter or something like that. But apparently that's not necessary.
Mm. Yeah, the little extra test case just to handle the palindrome separately. Yeah, yeah, that makes sense. I'm gonna be struggling through data structure algorithms on Sundays because I agreed to have a session with Omar and Fernando Sunday nights and Aditya on Sunday nights from 8 to 11 where we're solving hard problems together with dynamic programming solutions, specifically optimization solutions. So we're like really drilling down on specific solutions, and that's gonna be just Sunday night after that session. I'm not. If you talk to me, I would not. I probably won't even respond. I'll just be so short circuited. Yeah. So
Yeah, that's fine.
that's gonna be fun.
Yeah, I won't be here tomorrow because I'm gonna play soccer. So if you want to send me the problem or post a video or something like that, I can try to solve it. Maybe Saturday.
Cool. Cool. Yeah, I will send you the problem
Friday.
and I'll post the video.
Awesome. Thank you, man.
All right. Cool. Cool.
Bye, Liz.
All right.
Pleasure.
Good night.
Have fun at
Good night.
soccer. Good night.